Okay, we're going to work on number 7 and number 8 on 2.6. Okay, so we have a graph, and we're supposed to estimate the value of the slope at 1. So if we go to 1, we're here, and we're supposed to estimate the slope of this line, the tangent line right there. And it looks like it's about up 2 for 1. So that would be my estimate for this. Slope is 2. And then sketch an approximate graph of the inverse of this. So the inverse is the x's and y's switched. So if I go to here, I go 4, 1.5. This point would be 4, 1.5. So the inverse would be 1.5, 4. This point's inverse is over here. 1.5, 4. And this point right here is over 2.5 up 1. So inverse would be 1, 2.5. This point is over here. This point is 1.5, 0. So it would go to 0, 1.5. This point goes up to there. This point is at 0, negative 2.5. So switching that, negative 2.5, 0. And this point is negative 2.5, negative 3.5. It would go to negative 3.5, negative 2.5. And this point right on the line will stay there because it's negative 4, almost 4, negative almost 4. So it would go to negative almost 4, negative almost 4. It ends up the same place. And so there's the inverse. And now what's the slope of the inverse at minus 1? At minus 1, the slope looks like it's about 1/2. And at minus 1, it goes through 1. And before we were doing 1 minus 1, the slope here was 2 at the point 1 minus 1. So the inverse is at minus 1, 1. And the slope is the reciprocal. Here it was 2 to 1. On the inverse, it's 1 to 2, but not at 1. At 1 on the function, the slope is 2 for 1. At its inverse, we're looking at minus 1. The y coordinate becomes the x coordinate. So now we want to look at the x coordinate for the inverse. That's where the slope is the reciprocal. That's the idea of this one. Okay? Now 8. We're just going to try to take derivatives of inverse functions here. So first of all, the big picture is ln of all this stuff, and the derivative of ln of something is 1 over the something. So I'd have 1 over all of that stuff, 2 arc tangent x plus 3 arc sine x plus 5. So the derivative of ln of anything is 1 over it, because the derivative of ln x dx is 1 over x. Now, but the chain rule says then we got to take the derivative of the inside. So we got to multiply this by, so I'm going to multiply it by, so I can just write it in the numerator, the derivative of 2 times the arctangent of x. Well, the derivative of arctangent, as we worked out in class, the 2 would stay. The arctangent's 1 over 1 plus x squared. Plus, the derivative of arc sine we worked out in class. That's times 3, so it's going to be 3, and the derivative of arc sine was the square root of 1 minus x squared. And the derivative of 5 is 0. So that's the derivative of the first one. Now this has arctangent within it is natural log, and within that is this. So there's 3 layers of composite functions here. So first of all, arctangent. That the derivative of arctangent is 1 over 1 plus x squared. Whatever's in the x inside the arctangent squared. So we're going to get 1 over the stuff inside the arctangent is this. It's going to be 1 plus this stuff, ln arc sine z, this whole thing squared, because that's the derivative of arctangent. Now we got to take it times, because of the chain rule, the derivative of the inside. Well, the big picture there is ln, and ln is 1 over whatever the ln is of. So I'm going to have times 1 over arc sine z, because that's what ln is of. That's the x for ln, times the derivative of arc sine. Well, the derivative of arc sine is 1 over 1 minus whatever the sine is of, which is z squared, and in a square root. Okay? So C, we have a product. So we'd have to do the product rule. So we got to take the derivative of arctangent squared. So the big picture is something squared. So product rule, we have the derivative of the first times the second plus the derivative of the second times the first. Derivative of the first, well, it's going to be the power rule, because we got a power thing here. It's going to be 2 times the arctangent to the 1 times the derivative of arctangent, which is 1 over 1 plus whatever the arctangent is of 3t squared, times the derivative of the inside of that, which is times a 3. So all of this is the derivative of the first times the second plus, so I'm going to move the plus over here because we're going to have another mess on this one. We have a power rule, something to the 4th. So it's going to be 4 times that something, arcsine of 7t to 1 less power to the 3rd. So that's the power rule. Times the derivative of inside the power is arcsine, and the derivative of arcsine is 1 over the square root of 1 minus whatever's in that, and that's 7t squared, times the derivative of the inside of that, which is times a7. So I have the derivative of something to the 4th, which is 4 times that something to the 3rd, times the derivative of the something, which is 1 over the derivative of the arcsine, which is 1 over the square root of 1 minus whatever the arcsine is of, squared, times the derivative of the inside of that, which is times 7. That's the derivative of the second, and it's times the first, which is arctangent to the second of 3t. Not going to ask you to simplify it. That's just, all the steps on doing the chain rule and a product rule and inverse function derivatives. Messy, messy, messy. So for the derivative of this, we have ln of something, and the something has a quotient rule. So first of all, the derivative of ln of something is 1 over the something So that's the derivative of the big picture. Now this, since it's 1 over this, I could have written that fraction flipped over. But anyway, that's the derivative of the big picture, ln of something. But the derivative of ln of something is 1 over that something times the derivative of the inside. And that's where we have a quotient rule, which is going to be the derivative of the numerator. Derivative of arctangent of v is 1 over 1 plus v squared times the denominator, which is arc sine v plus v squared. Derivative of the numerator times the denominator minus the derivative of the denominator. So the derivative of the arc sine is 1 over the square root of 1 minus whatever the arc sine is of, squared. And then there's a plus, and so we got plus, the derivative of v squared is 2v to the 1. That's the derivative of the denominator times the numerator, and so we got the derivative of the numerator times the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. Now, if I'd done the reciprocal here, this would have been in this denominator would have been in the numerator and would have canceled one of these denominators. But the rest of this doesn't simplify very much, but this would have been fine for the answer. If you show this, you're showing me that you understand the chain rule, that you have to take the derivative of ln of something times the derivative of the inside, which is a quotient rule, which is going to have the difference over the denominator squared. Okay?